Welcome to Geography 485 585L, Internet Mapping. Module 6, Class Review. In this final lecture for the class, we will do a brief overview of the various topics that we've covered over the course of the semester and go back to the high-level perspective that will hopefully provide the final wrap-up in terms of where the different parts and pieces of the systems that you've worked with over the course of the semester fit together within the overall concept of a geospatial services-oriented architecture. So in this brief review, we will revisit the role of the Internet standards and technologies in geospatial applications. We will discuss the services-oriented architecture for geospatial data, products, and services, particularly from the perspective of the experience that you've gained over the course of the semester in working with those products and services in all the major tiers of that services-oriented architecture. We'll revisit some of the capabilities that you've learned for data management and publication with GeoServer, the web-based visualization capabilities that you've had a chance to experience using Google Maps and OpenLayers, our brief experience in working with desktop-based visualization and analysis in desktop GIS applications such as Quantum GIS and ArcGIS, and then conclude with a short discussion of how you can continue to use the capabilities that you have already developed and also what new capabilities and approaches you might consider as you continue to grow in your use and experience with the interoperability standards and data access and publication models that we've discussed over the course of the semester. So first, we can talk about the standards that we've had an opportunity to work with over the course of the semester. And by now, these will be quite familiar to you, but we will review them at a high level nonetheless to provide a context for our discussion of services-oriented architectures. As we've gone through the course, we have focused on both proprietary standards or approaches, say the Google Maps API, but we have focused more on the open standards that have really powered the development of the Internet as a whole and are continuing to enable a standards-based geospatial net, as we have seen with our work with OpenLayers and its support for the OGC services and the other applications that we've worked in as well. So key to the geospatial interoperability capabilities that we've worked with are the standards coming out of the Open Geospatial Consortium, including the Web Map Services Standard, or WMS, that we have used to visualize data both in desktop and internet-based web mapping applications, the Web Feature Services Standard, or WFS, which is, as you now know, a data access and delivery standard primarily focused on vector-based data, the points, lines, and polygons that are represented by geometries and their associated attributes, where the standard provides a mechanism for being able to access both those geometries and the associated attributes for display in either desktop or web-based applications. And the Web Coverage Services Standard, or WCS, which to date really is concentrated on in terms of delivering gridded data into desktop applications, which we saw a glimpse of as we worked with ArcGIS in particular, and its support for the Web Coverage Services Standard. We've also had a chance in the past few weeks in our work with GeoServer to work with OGC's Styled Layer Descriptor, or SLD standard, where It's the SLD standard that allows us to define the customized styles for both raster and vector data that we are publishing from GeoServer as standardized, customized mapping objects, where we can actually define styles and even multiple styles that can be affiliated with a web map service, where those individual styles can then be selected by the user for application in a particular mapping request. The SLD standard is not limited to GeoServer and is also supported in a broad range of other platforms that also publish OGC web map services. And finally, as far as the Open Geospatial Consortium standards that we have worked with are concerned, we also worked with the Keyhole Markup Language, or KML, as a standards-based method for encoding geospatial features and their associated attributes, while also being able to define representation information about those features and attributes. So KML represents somewhat of a hybrid between a data format and a representation format, and one that is broadly supported by a wide variety of both web-based and desktop geospatial applications, allowing you to share geospatial data and information about how those data should be represented to a wide variety of clients, particularly in circumstances where you might share those KML files over the internet and allow applications to access them remotely for display within their particular client interfaces. While the Open Geospatial Consortium standards are really the core of the geospatial capabilities we've been talking about, we also have worked extensively with a set of related, more general-purpose Internet standards. In particular, the standards that relate to the design and presentation and behavior of web pages, where those three characteristics are represented by standards out of the World Wide Web Consortium, or W3C, where the hypertext markup language, the standard language of web applications, really defines the structural content of a particular web page or website. As a complement to the structural information that you can define in hypertext markup language, you can also then define the presentation or styling of that structural information using cascading style sheets, or CSS, another standard that has come out of the World Wide Web Consortium, and another standard that really is the core standard for defining how features within web pages should be represented, both in terms of the basic information about colors, fonts, but also in terms of position and visibility. So those are the core aspects of a web page that you can define using cascading style sheets, where the structure is defined in HTML and stored within the web browser as a part of the document object model, essentially the collection of objects that are defined in HTML to which styles may be applied using cascading style sheets. The third leg of the web application triangle is JavaScript, a standard that has come out of ECMA as basically a programming language that is broadly supported within web clients, the web browsers that we all use to view content through the World Wide Web. Though it's not strictly limited to web clients, there are server-side implementations of JavaScript as well. but the primary use remains in the web client space on the client side. And so JavaScript provides a complementary capability to HTML and CSS in that JavaScript can define the behavior of objects within a web application. And it's JavaScript that allows us to have dynamic applications that, as the technologies evolve and the models for developing these applications evolve, are more and more closely approximating the experience that users are more accustomed to with on the desktop in terms of locally run desktop applications. And through the combination of incremental delivery of information through over the internet to a web client and behaviors defined in JavaScript, we are approaching the point where we have web-based applications that rival the performance and interactivity of applications that historically had only been able to run on off the local hard drive based solely upon local data. These services provide essentially the glue of the geospatial services-oriented architecture, where, as you might recall, this architecture includes at its core 3 basic tiers, which you can think of as containing or representing different capabilities when in combination allow for a more easily managed collection of data and processing capabilities to a wide variety of end-user or client applications. So if we think about the Geospatial SOA, in the bottom tier we have the data management component. And that is the component that you have been working with most recently in your experience with GeoServer as a platform for publishing data over the internet using the collection of OGC services, web map, web feature, and web coverage services, where you also are styling the content of those services, especially the web map services, using SLD as a mechanism for defining how those data should be represented when visualizations of them are requested. The processing services tier has not really been the primary focus of this course, though you have experienced that somewhat in the on-demand reprojection capabilities that have been provided by GeoServer, where you could think of reprojection as one form of processing service, where GeoServer provides a bit of a hybrid model, where it connects to data stored on the local file system, or, though we didn't work with it in this class, databases, geospatially enabled databases, or remote OGC services, and through access to those data, publishes the OGC services, but also is able to do some minor processing, such as coordinate transformation, when the spatial reference system is well defined for a particular data set. Moving forward, you can envision a time when, if you continue to work with Geospatial SOA, you might want to start experimenting with processing services that meet the particular needs of an application or community that you're working with in being able to deliver data or specialized derived data products to those end users. But again, in this class, our focus has really been on the data tier and then the user and client tier at the top of this services-oriented architecture, where the client applications that we have worked with over the course of this semester have included the Google Maps API, where that is actually an interface where you can use Google's servers and technologies to combine the data that they are managing as a part of their system with data that you might be able to also bring into the system through the application interface that you develop or KML files that you've placed in a publicly accessible, web accessible location that can be brought in and superimposed over the data that are published through Google Maps. Similarly, the open layers work that you have done, also in terms of developing web mapping applications, has provided you an opportunity to gain experience also interacting with the web map service in particular, but also see the potential of accessing remote web feature services or files, say KML, for integration into your web mapping applications as well. Our experience has not been limited only to web mapping applications, though. We have also, when we're talking about the client tier within this services-oriented architecture, also experimented with two desktop GIS applications, Quantum GIS and ArcGIS, both of which implement support for two or more of the OGC standards that we have discussed so far, where both support web map and web feature services, and ArcGIS also supports web coverage services. So over the past 16 weeks, we've had an opportunity to work essentially from top to bottom within this geospatial services-oriented architecture, allowing us to gain experience in the full spectrum, that full value chain, from having source data products, publishing them using a set of interoperability standards, and then accessing those data or data published by others using those standards. So by now, though we haven't emphasized at every step this services-oriented architecture approach, I hope that by now you understand that all the work we have been doing fits within this overall architectural model, this one of interoperable connectivity between data and users and clients, providing also the opportunity for processing of those data in an intermediate processing tier. Stepping back now to some of the work that we have done within each of these tiers, we can start with our work in data management and publication. And in that context, we have worked with GeoServer. And even in some of the precursor steps to get data into the condition that you need and to gain the understanding of data before you even bring it into a system like GeoServer for publishing those data as OGC services. We've worked with both the OGR and GDAL or Goodle libraries and sets of utilities to be able to gain an understanding of a variety of vector and raster data sets. We've been able to look at the output of the OGR info and Goodle info commands in determining file formats, the spatial reference system associated with data, the attributes associated with vector data sets, and some of the values associated with those data sets, so that we can more effectively bring them into GeoServer to be able to publish them using the OGC services. And as you recall from the illustration we have in the slide here, within GeoServer, we then go through a process of essentially creating a space to bring our data together, registering particular data objects with the GeoServer platform so that those data objects can be accessed in support of then one or more data layers that are the objects that are published by GeoServer for either the web map, web feature, or web coverage services published by that platform. We've also experimented with using the styled layer descriptor capability within GeoServer to define how particular layers might be represented given different characteristics of the incoming requests, including the ability to select particular features or feature types based on the attributes associated with those features, the values associated with raster pixels, the scale at which a particular map request is being requested, where all of these are defined as a part of one or more styled layer descriptor or SLD files that you can link to a particular layer that you have created in GeoServer, where those styles are then selectable by the users interacting with the GeoServer through the styles parameter in the OGC WMS request. In the data visualization side, as we're working within web clients, we also worked a fair amount with the Google Maps API, recognizing that Google Maps is a proprietary API or application programming interface that remains solely within the control of Google, where they can modify essentially the terms of use and the allowed use for the content of their mapping services, but nonetheless remains a very powerful and useful environment for being able to do geospatial visualization over the internet. And we worked quite a bit in being able to define custom symbolization that we can create using JavaScript and cascading style sheets to create our own customized interactive maps that allow Google to essentially do the heavy lifting in terms of map generation and handling interaction, leaving us to concentrate on the content that we want to present and the options for how we might present that content. The other web mapping application that we worked in quite a bit is OpenLayers, where OpenLayers is an open source, meaning that it is actually a project that is published in a way that anyone who wants to use the OpenLayers Java framework also has access to the source code so that they may actually modify it or update it to better meet their needs. Also translating into a broader community of developers that are contributing to OpenLayers, where one of the key differentiating factors between OpenLayers and OpenLayers-based mapping clients and Google Maps mapping clients is the broad support for open interoperability standards, such as the OGC standards that we have worked with this semester, as data sources into an OpenLayers mapping client. So as we saw in some of our exercises in OpenLayers, we can bring OGC web map service layers very easily into an OpenLayers mapping client. We can bring web feature service data streams into OpenLayers as a source of data. We can define features and their representation locally in JavaScript. And as you might have looked through the gallery of capabilities and options for OpenLayers, you can see that there is a very large number of options for bringing data into OpenLayers and for controlling how those data are represented. It provides a very broad canvas upon which you can paint your maps over the internet. where you have the interactivity that many users demand now in web applications built into the OpenLayers JavaScript framework, but tremendous flexibility in what data you can bring into an OpenLayers mapping application. Transitioning over to desktop-based visualization and analysis, we started and primarily focused on Quantum GIS, as that is a cross-platform in that it runs on both Windows and Macintosh and even Linux, desktop GIS application that also has support for the OGC web map and web feature services as components for data and map information that are delivered into the desktop visualization environment. And we had a chance to experiment with both web map and web feature services as data feeds into Quantum GIS. Keeping in mind that the ability to deliver geospatial data through web feature services into a desktop geographic information system allows for the integration of those data into analytic tools and capabilities that are available through that system. So with the delivery of actual vector data, the points, lines, and polygons, and their associated attributes to a system like Quantum GIS, you can then do further analysis and processing within the GIS where you take advantage of the fact that you know the shape and configuration of each of those features. You're able to look at the relationship of those features to other features within the data set or in other data sets, and derive new data from the data that you have, where you might be combining attributes or calculating new values based upon the attributes, all enabled by the fact that you can access those geometries and attributes via the web feature services support for Quantum GIS. We also worked with ArcGIS as an industry standard desktop GIS application that also has broad support for the Open Geospatial Consortium standards that we have focused on this semester, where ArcGIS has support for the three key standards that we worked with: web map, web feature, and web coverage services. And again, like Quantum GIS, with the availability of service support for the delivery of geospatial data into ArcGIS from remote servers, you have the opportunity to take those data and apply the many geospatial analysis and processing tools that are available within ArcGIS for developing new products or process-based outputs that make use of the data that are available through the web feature and web coverage services. While the processes for bringing the services into both Quantum GIS and ArcGIS are slightly different in terms of the mechanics within the application, we need to remember that it is the Get Capabilities request that is at the foundation for accessing the service metadata for all of the OGC service standards that we have discussed. And both Quantum GIS and ArcGIS use that Get Capabilities request and response to determine what information and data are available from the various OGC services, where these client applications use the information provided by those Get Capability request responses to configure themselves to effectively interact with the data services that are published by those remote systems. So you should always remember when you're trying to learn more about a particular OGC service that the Get Capabilities request is not just a request that desktop applications like Quantum GIS and ArcGIS can use, but it's also a request that you can use to read and interpret the information about that service before you even potentially integrate it into an environment like a desktop or web-based application. Let's now look forward in terms of some next steps that you can take with the knowledge that you've gained in this class and where you might go to expand your knowledge and and build upon the capabilities that you've started to experiment over the course of the semester. So based upon the technologies you've learned and the available resources that you have even while just enrolled at the university, you can do a number of things without needing to invest in additional hardware or software support or web publication capabilities. Those activities that you can continue today include the continued development of open layers mapping clients. As you've seen in this class, you can access a wide variety of existing OGC web map services and a smaller number of web feature services that are published for a diverse universe of data sets that are out there. Whether those data are published by USGS or NOAA or NASA or by local clearinghouses like the New Mexico Resource Geographic Information System, there are many and a rapidly growing number of existing data and visualization services out there that you could use as the foundation for open layers mapping clients that you can develop using just static web pages that you can host within your space that is allotted to you on UNM's servers. You can also continue to develop Google Maps and Google Mapping clients, where you've seen a number of methods for being able to build your own data that you might be able to superimpose on top of the base maps that Google provides access to through their Maps API. So you can generate, for example, KML files that represent particular data that you would like to present, or you can essentially bake data into your mapping client through JavaScript so that you can use the foundation mapping capabilities provided by Google and combine those data with web accessible data objects that you are sharing from, again, your resources that are provided as a part of the university in terms of static data or web content that you can publish from the UNM platform. And it's worth remembering the utility of KML as a broadly adopted data and representation exchange format. So as you are considering how you might be able to make the most efficient use of internet mapping or information sharing, KML remains a very useful form for some data to be able to create a KML file, say in an application like Google Earth, or even editing it within an XML or text editor of some sort, and then placing that KML file in a web accessible location so that you can integrate it either into, say, an Open Layers or a Google Maps client, or share it as a linked file that a desktop GIS user using, say, Quantum GIS or ArcGIS, where they might also be able to download that file and use it within their system. So you can get very efficient multiple use out of a single data file that you might share over the internet. Finally, as you have done all semester, you can use the existing space that the university provides you on their servers as a place for a static website where you can share information about yourself, your interests, or your work that is hosted on UNM's servers while you remain affiliated with the university. This is a nice way to be able to provide background information for yourself and begin to sort of stake out your location out on the web that you can then carry forward as you perhaps migrate that content to a new location after you leave the university. But being able to maintain and establish that initial point of exposure on the internet through the resources that are already available through the university, using the skills in HTML, CSS, and JavaScript that you've developed over the course of the semester. While the capabilities and technologies that you've worked with for this class provide a foundation that you can start to build upon, with the addition of some more resources or capabilities, you can go much further. And so if we think about what you can do tomorrow, as you possibly are able to bring additional resources or capabilities in support of what you want to accomplish, there are some new things for you to consider as you move forward in using the skills and knowledge that you have developed in sharing information about yourself, and even more importantly, participating in a community of geospatial professionals who are both sharing and using the data provided by the rest of the community. So one of the first things that you might want to consider as you look down the road and start thinking about how you can continue to engage in the broader community and again have a long-term identity and presence is to obtain a domain name that you can maintain as your own identity on the internet. This is essentially the first step in setting up your own freestanding resource out on the internet that you can brand using your own identity and approach. So, for example, many years ago, I registered the domain archeoworld.com as a domain that I wanted to have available for the long term that was separate from any of my identity that I have associated with the University of New Mexico. That is a domain that I can use as the foundation for a permanent email address that I can have for myself and my family, that regardless of where we work or how we move through life, as long as I maintain that particular domain, we can always have the same email addresses. A domain name is also often a prerequisite for setting up your own services on other systems if you are going to share data or set up a website. So instead of, for example, as you're here at UNM, using your provided space on the UNM servers where your web address is www.unm.edu/your username/index.html, you can instead register a domain and have as the web address that you have available out on the internet for people to access as something like www.mymaps.com. I'm sure that one is already taken. But you can start to think of how you might be able to use a domain name that you own and that can be acquired very inexpensively, that you can use for the foreseeable future as a consistent identity for yourself on the internet. So in the future, if you ever decided to, start a blog that relates to geospatial information, or your favorite hobby of collecting cat videos from YouTube, you have a consistent identity that you can use to link whatever your interest is to a known address on the internet. I've listed here a number of the nearly infinite number of domain registrars where you can search to see if a particular domain that you're interested in is available and where you can register it. I have worked personally with hover.com. That's my particular domain registrar at this time, but there are others, and I would look to the community for information about the good, bad, and indifferent information about any particular provider that you want to work with as far as domain name registration. Once you have a domain, you can start to continue thinking about how you might publish or share geospatial data using the open standards that we've been talking about. And as a part of that, you might start experimenting with alternative server platforms to the GeoServer platform that we've worked with, where two other major platforms that are very broadly used include MapServer. We mentioned that briefly when we started talking about the server implementations of the OGC standards that we've spoken about. MapServer is the platform that we use at the Earth Data Analysis Center for many of our online mapping applications. It's the foundation for the New Mexico Resource Geographic Information System. And then ArcGIS Server is another very broadly used platform for publishing data over the internet, both for consumption by ESRI's own web mapping clients and desktop mapping clients, but also optionally publishing data using the OGC standards, where that is a capability that you can use to publish data both to the market of ESRI GIS users, but you can also publish the open standards-based services that other applications and platforms may be able to use more efficiently. The other thing you can do after you have perhaps looked at some of the other map server platforms for publishing the services is you could then establish an instance of your own of one of those platforms. So whether it's GeoServer or MapServer or even ArcGIS, you could actually set up and host a platform that you can use for sharing your data with the rest of the community, so that as you generate and collect data, you can publish it using the OGC web map, web feature, and web coverage services and advertise those services through clearinghouses or other online resources such as geo.data.gov, which has now been the successor to what was formerly the Geospatial One Stop, a U.S. National Registry of Geospatial Data and Services. But once you have established a mapping platform, you are then a contributor to the community of geospatial data users. And the question might then come up, how can you do that if you don't have access to a machine room where you could put your own server and a dedicated information technology IT support staff to help maintain that server? And this is where you can start looking at a variety of platforms or services where you can set up either a basic website, which Squarespace is an example of, where on Squarespace that is primarily focused on website and blog type applications, where they provide a very nice interface for being able to create and update and maintain an online presence I use Squarespace as a platform for publishing my static web content and also for occasionally putting data that I want to share over the internet. Kari.net is a cloud computing provider where they have large data centers where you can set up essentially a virtual computer in their environment where you can set up and maintain your own applications, including all the server applications required for web hosting and GeoNetwork or map server. Amazon EC2 is another platform for doing essentially cloud-based server computing where you pay by the hour for a computer that is hosted on Amazon's infrastructure, where you can establish whatever combination of applications that you want to run on that virtual machine that is hosted within Amazon's infrastructure. We also have a variety of more specialized hosting services that are specifically designed to support geospatial applications. And 3 examples of those are provided here. And while I haven't worked directly with any of them, they provide examples of the types of services that you could look for in a hosted geospatial platform where you might be able to share your data or develop web mapping applications that are available persistently over the web. And these include MapServer Pro, a company that specializes in hosting map server-based applications and data. QGIS as another, in this case, ArcGIS hosting platform, so that if you wanted to use ArcGIS as the server platform for your data, you could use a system like that published by QGIS. Or GeoCortex, a company that provides a platform for hosting GeoServer-based services. Where, again, these are just examples of the types of providers out there that you can find where you don't need to maintain your own physical server that is connected to a network connection that you have to maintain, but instead you can essentially rent or lease capacity on a monthly basis on any number of platforms like those that are listed here to host the data or applications that you would like to share over the internet. So with that, I encourage you, as we are now completing our last lecture of the class, and we'll be performing our last lab assignment for the semester, focusing on bringing the data that you have been styling in GeoServer into one final open layers based mapping application. I encourage you to bring any additional questions and discussion about any of the materials that we've covered over the course of the semester to our Tuesday afternoon collaboratory. And if you can't make it into the collaboratory, we can go ahead and have a final set of online discussions on the class discussion board. So I hope to hear from many of you, either in the collaboratory and in the discussion board. And I hope this has been an enjoyable course for you, and I hope that you have now seen the benefits of both using and understanding these open interoperability standards and the resources that are available over the internet, and even more so that you're going to look forward to contributing your data and expertise to the broader community as we can expand the use and reuse of critical geospatial data for answering key problems and challenges, both in the public sector, in education, and in basically answering the questions that businesses need to succeed. These open interoperability standards and services-oriented architecture models can help us address all of those questions more efficiently and with better exchange of information and data for the long run. Thank you.